Hey, hi, Miss Sundberg. I'm using some fun animated things that we have on our Zoom accounts, so I can come to you looking like some Christmas themed man, I guess. Um, if you don't celebrate Christmas, just know that the red and the green are these colors that we often associate with Christmas. So in my family, I celebrate Christmas. Let me know what you celebrate and if there's any specific colors that go with that. So I'm here today to talk to you about acids. Acids are going to be so important as we move forward. You're going to be given compounds galore and expected to name them when we come back to in person, which we will. You're going to be using acids in so many labs, and so you really need to know how to name acids. And one of the important things that you're going to want to do is this page right here where I have all this information about acid names, like this stuff. You are going to want to write that down on your periodic table somewhere to know or remember these because they're really important. So here is kind of how this works. When you have a compound that starts with H, okay, H, and then it has something after it. Okay, it could be HCl. It could be H2SO4. It could be C2H3O2. Okay, it could be anything that starts, as long as it starts with an H. Okay, if it starts with an H, that tells you it is an acid. Okay, and that's one thing a lot of people have problems remembering here as we move forward. But all acids start with H. So check this out, H2O, that's an acid, okay? So when we name compounds, like we've traditionally done, we have three different endings. We can have an IDE ending traditionally, we could have an ATE ending, and we can have an ITE ending. Any one of those endings, if they have that ending, but they have an H in the front, like all of these, they become an acid. And what happens is that ending goes away. That ending now becomes ic acid, and then you put hydro in front of it if the ending was IDE. Okay. If the ending was ATE, one of those polyatomics, I can write that down. ATE is a polyatomic. Okay. If it ended in ATE, you would drop the ATE ending, add IC, and then acid. And if it ended in ITE, another typical polyatomic ion, if it ended in ITE, you drop the ITE and add OUS if it started with H. Okay, so we have a bunch of common acids here. So for example, if we take any one of these, if I take H and then add it to the Cl, I'm going to get HCl. Okay, so because that ends in IDE, okay, because that ended in IDE, what this is going to become is that IDE becomes hydro. And then we stick with this name that comes next, chlor. And then we have the IDE or the IC ending that it changes to, and then acid. Okay, so let's just color code this. Because it had the IDE ending, you have hydro, ic, and acid. Okay, but that's when it starts with H, as you can see here. Okay, moving on. I'll do another color. Let's do green. Okay, carbonate has an ATE ending. Okay, with the ATE ending, if I were to add hydrogen to this, this is going to go and become H2CO3. And that is the carbonate with an ATE ending gets dropped and it now becomes ic. So it's going to be carbonic acid. Okay, and moving on, if I were to put an H in front of NO2, and NO2 is nitrite with an ITE, that ITE ending gets dropped and it becomes OUS, and so this would be nitrous acid. Okay, So a couple things. Naming acids. Do the compounds have a hydrogen atom as the cation, the first element? That's your first check. If that's the case, you have to name it as an acid. Okay. Then check the endings. Okay. These endings I have listed up here. You're going to want to, like, I don't know, memorize this or write this down, but you want to have access to this. This is like super important right there. Okay. And the anion ends in IDE, it becomes hydro and ic, and then the word acid. Okay. If it ends in ite, it becomes OUS and acid. And if it ends in ate, it becomes ic and acid. All right. So let's try a couple of these and we'll move on. So we have H, right? So H is given, right? We can just kind of ignore that. This BR, one capital letter, so we know it's going to be bromide. Okay. Now, if you remember, the IDE goes away. Okay, we can cancel the IDE. I'm going to go ahead and move this in the middle. Then I have to add hydro in the front because it had an IDE ending. I'm just going to write that. Okay, hydro, and then we have the ic. Oops, I'll do that in black to keep my colors consistent. And then acid. And this is all because it had the IDE ending. Okay. All right. Let's move on and try some other ones. Let's do the next one. HI, hi, the high element. Sorry, it's been a long day. Okay, so I, one capital letter, which means we find it on the periodic table. So it's going to be IDE, and it's iodide, right? Iodide. And so this is IODIDE, okay, iodide. We cross off the IDE. That gets replaced with hydro, ic, and acid because it was IDE. Okay. All right, so finish this top box. Let's move to the next box. Moving on, we got a whole bunch of other hydros. Okay, hydro, ic, acid, hydro, ic, acid, hydro, ic, acid. Okay, all of these on this page are hydro, ic, acid, which wasn't very smart of me to teach you this, but you'll get opportunities to do some more down here. Okay, so hydroic acid, if that is the case, if you see the hydro, you know it probably ends in IDE, which means sulfide is S with a -2. Okay, the positive ion, these are all acids, so they all will start with H. Every single one of them will start with H. Okay, moving on, we have chloric. Chlor used to be chlorine, and chlorine is Cl with a -1 charge. Okay, next one, hydroarsenic. Okay, arsenic. That used to be arsenic. Arsenic is AS. Okay, AS. And AS has a -3 charge. Okay, arsenide is what it probably was. Okay, moving on. Fluoric, that used to be fluoride, and so that would be an F with a -1 charge. And hydroiodic acid used to be iodide, so that would be I with a -1. Now we would crisscross charges. H2S, HCl, H3AS, HF, and HI. Okay, so that's all for the IDE endings. Let's move to the next part. Now we have endings all mixed up. We have an OUS ending, an IC ending, an IC ending, an IC ending, an OUS ending. Okay, these are where our polyatomics come into place. That's why I have this ion box here for you. okay? So a couple reminders. If you have an OUS ending, that up here, if we go up here, okay, if I had an OUS ending, that means it was ITE. All right, so originally it was ITE. If I have an IC ending, that means it was originally ATE, okay? So let's take a look at this. Sulfurous acid, okay? It ends in OUS, so that must mean it used to be sulfite with an ITE ending. All ITE and ATEs are right here on your periodic table. They're the polyatomics. So look up what sulfite was, and sulfite is SO3 with a -2 charge. It's an acid, so we know H comes first. Now crisscross your charges, and you have your formula. Okay, moving on. IC, okay? IC used to be 8. Salicylic acid. It used to be silicate. Okay, so I'm going to look up silicate in my polyatomics. Okay, silicate is SiO3 with a -2 charge. It's an acid, which means it starts with an H. So now I have my 2 ions. I can crisscross my charges. I'm going to have H2SiO3. All right, folks, I hope this helps you figure out how to do this and gives you some help of how to do this. So if there's questions, reach out, let me know. But again, you're really going to want to have this information on your periodic table handy. I don't think I put that on your periodic tables anywhere. I should. All right, take care. We'll see you a little later. Bye.